Welcome back. Today we're going to be talking about the database set operations using Oracle SQL. These operations are fairly much the same across all the databases. I'm working with Oracle's SQL developer to specifically work on this. You can take a look at my set operations study guide. It's available on my GitHub resources page. You can see I've got some study questions to use to go over that, making sure to understand the concepts and the stuff we're working with as we do that. But we're going to talk about how we can actually do those practices. So let's go take a switch over to SQL developer. We'll go from there. Again, as with everything we've been doing inside this, we're working within the Alice Richard text, the Oracle SQL by example. So I'm using the examples from that so we can do demonstrations to go over that. But these operations, of course, work on any database you're working with. This is just what we're using to do the demos on that. And so we want to do a couple different demonstrations. We can see what's happening as we do the demonstrations themselves. So we can look at the operations themselves, what's happening inside it. And so the first thing I'm going to do a quick little query right here. I'm going to grab as an information to start off with that. As you can see right here, I have student.firstname from student2, where student first name is greater than M. So I'm going to get all the first names of my students. If I run that query right there, I have that lovely pile right there, 118 rows, all the first names. And if I do the same thing right here, I'm going to grab one more query. I'm going to grab the zip.state and also grab that from M right there. And run that query right here. I'm going to do the zip.state where from zip code zip where also state is greater than M. Same basic query right there, and I've got 206 rows out of that. Wonderful stuff. So I've got lots of data, all the things greater than M, because I've got every single entry inside state that has an M zip code or an M state. And I've got lots of dupes. That's okay, or greater, which is wonderful. But we're going to use the idea of the union operator. And so union, if you're looking at the idea of working with the lovely magic power of Venn diagrams or Euler diagrams, you have the nested set of circles that look like this, and you have the little thing on the left and the right and the middle section right there. And so when we're looking at the idea of a union, we're looking to see what is in common between both sets. AKA, we're looking at the entire picture right there, both the left circle and the right circle. And so I'm going to use the union on that. And so we'll do the union command right here, and just join it in between the two queries. And so when I'm writing a union command, I just put a query, the command union, and then the next query as well. And so I'm going to go ahead and just wipe out those that structure there so we can see what happens and rerun that query. And now I have only 99 rows. What? But I had 200. Oh, union. The power of union is it takes out all the dupes. But wait, there's more. Not only does union take out of the dupes for us, notice what happens with our data set right here. Our data set's returned is sorted alphabetically. I know, it's amazing. And so union's a really cool thing. And so here I can get all the student first names and zip codes greater than M. Why? Well, it's random and it works, but that's okay. And so that's how we can have this happen. So the union command takes the results of a table with the results of another table and squishes them together in a single solid entity. But notice I only have one single column. It's not like I'm doing a query. I'm going to grab all the things and put together in a join where I get two different columns. And so if I take a look at something similar to that, if I were to grab, for example, all the first names and last names of all my instructors and students, if I were to try to do that as for example, a query with that using regular like join type operations right here. I'm going to grab everything from student first name and last name and everything from instructor first name and last name and do it as S name and I name. Really great, lovely use of subqueries as well. Great stuff. And I pull that together and oh my gosh, 2,600 rows of useless garbage because I combine A. Tucker with every Irene Willig and all that same thing all the way down. I have that massive, ridiculous duplication, massive, horrible. What's it called again? Oh, that's right. It is a Cartesian join or Cartesian product. Oh, I know, we don't want that. We never want that because we never want to actually grab that. But when we're doing a join, we're putting columns together of information. However, when I use a union, let's go back and do that right there and clear that right back out. When I do a union, I'm combining my rows of information. And the really powerful thing about union is it grabs me all of the stuff and takes the dupes out and puts them in order. If I make one slight itty bitty change and add the all operator on top of that, union all, I get 324 rows and dupes, and oh, it's not sorted anymore. Sad face. Very much not the best thing. And so union all, most of the time, not the right option. The only time I really use it is when I'm doing the idea of combined insert statements to get together a big, huge table or put something together with that. But that's another thing entirely. We'll talk about that another time. We talk about inserting stuff into a database. But the next thing we have to do when we're talking about the idea of our set operations is we want to do the idea of an intersect. And an intersect works a lot like a join. And so I'm going to go ahead and grab an intersect example right here. And so we have an intersect option again. And so again, with all of our logical operations, when we're doing the operation, we have our query we generate on the top, the first operation, then the keyword for our set operations, and followed by the next query we're combining with that in a logical structure. And that's the intersect. And again, when we're talking about intersect, it's that little itty bitty section in the middle between the two, the AKA the stuff that's only in common between the left and the right side of a Venn diagram. And so in this case, I have select instructor.firstname from instructor INS. I'm intersecting on student.firstname, student Stu. Oh, okay, cool. I run that query right there, and the only thing I have in common on that is Charles, Gary, and Tom. Those are the only commonalities between the student table and the instructor table on the basis of first name. Now, what we can do, however, is I can take that same lovely intersect, I can do that as a join. I can actually do an echo join on that. Now, not a proper join, because unfortunately, in order to do that, well, it's not going to be done as a lovely, really good piece of code. As we take a look right here, we have a select instructor.firstname from student Stu, instructor INS, where inst.firstname is equal to stu.firstname. Notice it's not a notice that it's not a proper foreign key primary key relationship because I'm not doing a real good join. Oh, I know, never a good idea. But on top of that, I'm also using a comma to separate my tables and my from clause. Ugh, I just feel all icky when doing that. But watch what happens when I run these two queries. I've got the same results. So it gives me the same information, but this is clearly the superior way to combine disparate information in a single row because the intersect actually grabs that information. However, you can do it as a join in the wrong format because, again, notice how I'm using my where clause to do my combination operation. Not the way we want to do it. That's where an intersect really comes into play because we want to use the best proper code for the situation as we do that. And so we can do an intersect as a join, but we really shouldn't. Intersect, if we're trying to actually combine rows of information across tables, that's where intersect comes into play, and that's the proper way to do it. Also, the nice thing about that, notice how intersect, it alphabetizes it versus the join, it doesn't. I know. There's a billion six reasons why intersect is better, but that's okay. The last one we want to talk about is the minus operator. When we're doing a minus operator, we have the idea that we're taking a table and a table, flump, but I don't want to get the middle part, and I definitely don't want what's on the other side. And so when we're doing that, we have the first selection minus the second selection, and order really matters. Just like when you're doing subtraction into the regular math land, if you put the bigger number on the right-hand side of the minus sign, you're going to get a negative number, which is different. So we have to keep that in mind that when we're doing those subtraction operations, that the order itself matters. And we'll see the example of that here in just a second, but keep it in mind, order matters. So we have select student.firstname from student Stu minus instructor.firstname from instructor INS. And I run that query right there, and I've got 202 rows. So I have all the students' names that aren't in common with the teachers' names, which is, okay, cool. We've got 202 rows that don't match. But again, notice, sorted data. I know, it's great stuff. But if I do that the opposite direction, I'll just grab that and paste it right here, and paste, select instructor first name from instructor INS minus student first name. So it's just in the opposite direction. I'm taking it from this side now. I'm looking at this side only, and I'm not including anything that's on that when we're talking about the actual structure. I'll run both of those queries. I have 202 rows selected for the first set. My second set only has 7 rows. Ooh. Yeah, so we definitely want to keep in mind that when we're talking about the idea of a set operation, order really matters. When we're talking about the order of operations of set operations, it starts at the top and works its way down. If you need to nest anything deeper, we use the magic power of parens, just like in regular MATLAB, to do combined results and do that kind of stuff. But that's all it takes to do the lovely bit of set operations. Again, we demonstrated how to use union, union all, intersect, and minus. And we notice again that when we're talking about using intersection, that we want to do the intersection of data, we use intersect instead of the bad join because it just feels so icky. But that's what we're doing for that today. Hope this is helpful. Cheers. Have a great day. We'll see you next time. Bye-bye.